Okay, so yeah, it took forever for me to find a data source. Like, I would tell you, like, I spent a lot of, I almost bought the money. Like, I was like, should I buy data source and like expense Amir or just like, for it just given the sensitivity of information in fraud, there is no available data source that we can find. Right, there is nobody will share the fraud data. Like, if they shared it, like, be very suspicious of it. So at the end, I find in one of the Kaggle problems that there is some sort of synthesis data. It's called pacing, that simulate mobile money transaction based on the real transaction they promised, and it's based on the system that implemented in Africa, in an African country, but they said they have a fraud, some sort of fraud detection in data. We will see there is a fraud, flagged fraud in data, and there is a confirmed fraud from the, I think, the call centers. But this is not real data, and at some point of the analysis, you would see why it's not real data. Like, it shows it's not real data, but it's a good example. Like, that's the only example I could find actually that works a little bit as well. So the first line is importing libraries. That's easy, and then mounting your drive, going here. We have time, lots of time to discuss, because later on.
Is it possible to make it bigger? So.
It's a very small.
Yeah,
how should I do?
Command plus. Alright, cool. That's good.
Oh, the man, it's, I don't know. Oh yeah, I know. I'm sorry, it's my fault.
Oh, I see.
Is that like an ice saver or something?
Yeah. I after I cannot look at the blue lights.
I have that too.
So did I do that? And then go to the, it's a usual drill. Go to session 3, look at what it's inside the session 3, and read the data. It's called paysim.csv. It shows how big data is.
So what is this data set?
I said it, like, it's a it's a simulated data based on the real mobile money transfers. Data has columns that the steps, each step shows an hour, and it's up to 30 days of data. There are types of transfer. It says what type of the transfer it is, amount, name of the original sender, balance before sending money, balance after sending money, name of the destination sender, balance before receiving money, balance after receiving money. Is fraud is actually fraud by, like, it's marked fraud as by an agent, and is flagged fraud is marked by their system. So just look at how data looks like. Again, like you can see, is an hour one type, different type of payments, different amounts, all in the same currency, name, origin, old balance, new balance, destination, and all this one. And is fraud one means it's flagged. Sorry, is fraud one means it's fraud. Is flagged fraud one means like the system caught it. So to understand the data a little bit better, I just ran, it's just some sample analysis. So look at the fraudulent one, analyze. I'm selecting anything that is actually a fraud and dropping duplicates and printing printing different type of the fraudulent. I just want to see if all the types hit the fraudulent account or there is a specific data that fraud, and again count the frauds. So type of the fraudulent transaction, or there are only two types you can see if there are fraudulent transaction, is a transfer or cash out. I don't have much of information as a data, so I'm not sure what cash out means at this point. I add this data. Yeah, but there is a destination value there as well, so I don't know what that's. And I look at it, like sometimes people cash out and the destination node become richer, so there's some sort of money transfer happen. I don't know how. The number of fraudulent transfers is 4,097. The number of flagged as a fraud is 16, and the number of fraudulent cash out is 4,100-ish. So the flag is practically useless. One thing I don't have it here.
There's a question online?
Yes.
Okay. So the question is,
I just wanted to say something.
can you explain this, given the fact that the flagged transactions are 16 out of 6 million data?
Yeah.
And apparently, based on the extensive data analysis on this data set on
I
Kaggle.
haven't received either yet, but yeah. It's my sentence on the next sentence, literally.
Okay, there's no logic behind why the 16 transactions are marked a fraud. We can safely ignore those values.
Yeah, it's a bad English, but do you want?
No.
I just want to say.
That.
It's a sentence I wrote here, and practically we see
I see.
16 flagged value, right, out of 6 million data, and then like there are 8,000 actual fraud, right? So like 16 over 6 million is practically nothing, right? It means that we don't know what's the logic behind that. Hey, we don't know how the system works. Their system, the fraud detection system works. It obviously doesn't work well. And we cannot find any logical. We cannot reverse engineer their system based on the 16 flagged we find, right? It's just like, based on all this information we have, we just drop that value. We just ignore it, right?
Meantime, you've got 8,000 actual
fraud
to worry about.
Yeah, exactly. Does it make sense? The person who asking.
It also just seems odd that the flag count is so much lower than the fraudulent count. Like this fraud count.
It's like they looked at the view and then went to lunch.
Yeah.
Flagged one is their detection system. So it's
very low.
Yeah, it's very low.
Yeah.
I just want to say, like, so out of the ones that is flagged fraud, there's 16 of them, they're actually all fraud. So the precision is 100%, but the recall is so bad.
Yeah. That's
So bad it's
also
pretty
So when they say it's fraud, it's actually 100% fraud. Out of the 16, it's actually less fraud.
Yeah, but like the rest of it, like.
But yeah, they can't capture all the fraud.
So something is important on graph, and I was very, very redundant on getting rid of data, is if you, I'm so sorry, I'm forcing you to change it. I think I put my leg on the. Are we okay?
Can you try to draw on this map?
This side? Okay, I'll try. Okay, I drew a network here. So today and like yesterday, and being old astronomer, I've drawn my nodes as a stars all the time. It's an old habit, sorry. Like. So Kahal today and like the whole last year was like, sample your data, make it easier, sample your data. Because the whole last year I was like, it doesn't run. Like, I was panicking the whole week. I was like, it doesn't run, it doesn't finish. I was like, sample your data, sample your data. But I give up. I sample my data. But I was very reluctant to do that. And the reason is that, like, for different type of connections, you would have different structure, right? There are so many different type of money transfer that shows the connection between people, and you would have some description. So imagine if you sample your data, or even get rid of the transaction types. You would, for example, get rid of this edge, or this edge, or this edge, like, especially if you do it randomly. Or you might keep this one as well. But then you break the connections, right? And in some graph detection, that connection is like graph techniques detection, that connections are important, right? If you break this connection, you're practically breaking the VOC, you're practically breaking a VOC here, right? And you should be a little bit cautious about it, on how you sample data when you are creating graph, because that VOC, the length of VOC, sometimes has become very important factor in your graph. And also it breaks the communicativity as well. Like, you break something here, you remove this node, this edge, it's a simple, it's nothing. Like, you still have a node, you remove the edge, and then suddenly this person is cut from this community, right? And become anomaly or like some project. So it's when you work with graph, be extra cautious on how you sample it.
So what is the most simplest way to sample?
Not doing. That's the most safest way.
But you can do different methods, right? You could prune, but you could also just aggregate, like everything just goes into this one node.
Yeah.
But that takes a little bit more time and also takes a little bit more consideration.
You would
but
see it
probably
as well.
would be better.
Yeah, you will see that not, like, aggregating takes the time. But at the end of the, good. So at the end of, after like lots of time, I gave up. And I decided, because we only see fraud in two types of the data, we just keep that information. So we keep type transfer and type cache out, and then, like, for the rest of it, it's just, for rest of analysis, I need all this collection. I just brought them here. We select list of senders, list of destination. We select subset of the graph that we select only fraudulent activity. We select victim, and list of victims, and list of frauds. We assume if is fraud is 1 and we see the fraud, the original person is a victim and the destination is a fraudulent. So this is our assumption. That's why, like, I misspelled victim, right?
Yeah.
Yeah. When I was typing, I knew it, but so we have victim, we have fraud, and then, like, we have a benign accounts, like sender of all the benigns and sender of all this destination of all the benigns, right? And because this is money transfer from one node to other node, it's a directed graph for sure, because one person send the money to other person. So for selected reason, white out. Remind me if I don't run some part of it. So again, look at the schema. Now we only have transfers, cash outs, transfer and cash outs, and different balances. So something is interesting, you can see right away here. This data has problem. So the amount of $181 went out, but it never received in the destination. And it's fraud. So yeah. Also, yeah, the same here. Like the amount of 181 went out and never received. Like new balance is 0.
Is that a typical way that fraud would manifest, or could the money not have been? Could somebody send money to somebody to a destination that they didn't?
But yeah,
they
this
didn't actually want to send anymore.
in the transfer is the same. There's an issue with the data.
Oh, it's a data issue. It's not somebody intercepting it, not the non-intended.
No, like it's you see, like road for like is against an old balance, new balance. For the destination, it doesn't change. Logically, you would say, like if a transfer from destination, the old balance should be a month plus the old balance.
Yeah.
Right?
Maybe they robbed the destination account.
I was wondering that. Yeah.
But it's not marked as.
But this one is not fraud as well. That's. The data has lots of problem. I noticed it at the later stage of the day, but I didn't have chance to. I just want to show you the ideas here.
Sometimes you don't know if it's a data problem or it's like a type of fraud.
I mean, I guess it could be a type of fraud, yeah. But sometimes your data is just dirty.
Yeah. So, okay, this is what we have. And then now we are working on graph. So for graph, I use Network X. It's a very powerful Python graph. To do that, I imported Network X as NX. And the good thing about Network X, you can just read the edges from the pandas form. So you just get the data frame, panda data frame, and you can just describe the columns as edge. So here, which data frame I chose. If your graph is directed, you have to say destination and starting node and destination node, right? So the first input name.orig would be your outbound node, the first, like what they call it, source node. The name this would be your destination node. And if it's not directed, you have to define only one column. You can define only one column as your node, so you don't need the second column. And here you have to provide list of columns that you want to use as attribute, as an edge attribute, as edges, sorry, as a relation. So amount of the money sent. It could be so many things. Frequency of the time that two nodes connected to each other. It could be amount of the money sent. It could be like, as I said, it's a list. It could be both of them. It could be like, I tried with different columns, but I think the most important value we need is like how much money sent between these two.
Knowledge you have, like you know what you care about is the origin and destination. This is how you chose those columns to be.
Let me finish this one because it takes a while to run, and then I talk about it. And then we go through print nx.info. It just gives us info about how your graphs look like. It was running. So the question was if I put some pre-knowledge. Yes, I put it. So what I want to detect here is to define, to find the fraudulent email money transfer, right? Sorry, fraudulent money transfer through mobile. To do that, I want to create a graph of people send money to each other. That's what I want to create. I want to see, okay, first people send money to each other. That was fast. Okay, faster than Office. People send money to each other. What's the relationship between them, right? How they're connected, like what's the information based like on connections? I would say this is something I play with it all like few days, and I come up with a month. Like I went through the whole code. I was like, okay, it's useless. This one is useless. Like the first thing I did. You can just say edge attribute is true instead of defining list, and takes all the other columns in your data frame as an attribute of your like connection between these two, right? And like I defined, for example, new balance, old balance. of the original, of the destination. Like I define like I play with lots of them. A number of the connection between them, aggregate them. Amount seems like one of the logical ones, right? Like,
There's a lot of combinations.
there are lots of
Right, yeah.
combination, and again, it's your expert, your fraud expert or person who works with this data manually, like your business, usually can help you. Or your cybersecurity experts can help you to define these features. Or you can do what I did today. Like I played with lots of them and just delete them. Like if you look at the version history, like different type of frauds are there. I just delete them. Let me know when we get the break.
There's no like equivalent of PCA or something like that, or
You can do the PCA and just like okay.
You can use spectral methods on graphs as well.
Yeah.
Um,
Not suggesting that. It's very time consuming.
yeah, and it's also not incredible. Spectral methods. I think we look at the spectral.
One thing about the graphs, I didn't talk about it because it's mathematically heavy and time consuming. You can define a graph as a matrix. You can transfer a graph to a matrix and do all the graph analysis with the matrix analysis. So a spectral graph, you can do it on the matrix as well. It takes lots of time though, right? But the beauty of the graphs is you can just show them as matrices and work with matrices if you are not happy with, like you are not, like, it's a transferable, right? And for different type of graphs, for different type of graphs, there is a different type of matrices you can define that how you transfer them.
Yeah, I was just going to say, like for certain graph problems, like you can also just use the matrix. So for PageRank, you can just use the matrix.
Yeah.
And yeah, it's just much faster that way.
Yeah.
Like, because it's matrix multiplication.
Yes.
These are sparse matrices.
It depends on how they connect it.
That's a very good question.
I
Typically-
think they are.
Yeah.
And then for spectral methods, what's it like? In spectral methods, you have time or space typically or something.
It's really eigenstates and eigenvalues.
Yeah.
So it's eigen decomposition, and it's generally that doesn't.
It's
Complexity is like n squared, I think.
I
So
think
it's
like
not a great method to use.
it's massive. Like for a big graphs, like it become like massively heavy computational program. I know it because one of our cops tried it, and the bill was expensive.
Cheaper algorithms for finding the the maximum eigenvector. So if you just want to know about the principal eigenvectors in the graph, you could do that in more efficient.
Yeah.
Okay.
I think though the main moral I think we found is that spectral methods aren't really all that amazing for graph problems.
I think the graph analysis are more optimized, and like I never worked with, like, as I said, my experience with the graph comparing like either was from high school or the co-op experiment, and it wasn't cheap experiment. Like, it's time consuming and like source consuming.
But you're right about the principal eigenvector, and that can be used for like community detection and things like that, right? And it can be good. Depends on the problem.
And like size of data, like I would say. Have you have any experience on that, like, or tell us? Okay. Yeah.
I've noticed that graph databases, in particular Neo4j, have been facilitating specific analyses lately. Are these at all related to the machine learning content we're learning today?
I don't like graph Neo4j, or there are graph stacks. There are like lots of different graph databases. They have their own language. It's called Cypher. Yeah, Cypher. I don't know how to use them. Like,
I personally think it's a waste of time.
for visualization, for usage, it's good. It depends on how it's implemented in with your infrastructure, I would say. It's always back to your hardware, right? Like.
But so this embedding style approach, the graph analysis, enables us to do whatever you might be able to do with like graph
So what they provide is graph data. Like, you can talk about it more because if you use more, they provide the capability to create graphs easily and then put it in graph database and analysis and everything, right? But you can do it with Python as well. And the things they provide and Python doesn't is a visualization. It's like, are you agree with me or not? Yeah, visualization part, I think it's really important. Yeah, Cypher is a language, and another language you have to learn. And yeah, it's hard. It's weird. And I think we are so comfortable with Python right now. That's our problem at this age. But you can transfer all this knowledge to Cypher and apply those there. So I tried to visualize a graph. There are a few techniques, like few small codes, to show how our graphs look like. I trashed the whole thing like quite a few times, and I just decided to put a warning, just comment out everything. In the morning, like Kahal tried it, and then I ran like to just comment out everything, like do not trust the ignore part. If you want and you have time, just go at home and run this box, and it shows you run one, like either up part or down part, like not all together, and it will show you a graph if you're lucky after a few hours.
So how do you, like in your day-to-day work, like how do you iterate quickly on discovery in that sense?
We don't do it quickly.
Okay. What's the quickest iteration technique you've discovered so far?
Again, like we use lots of inside knowledge.
Okay.
Right? We use lots of inside knowledge that, okay, if you take this type of the customers or this type of the network, it's not connected to other side of the networks, right? So just this one. You don't break the whole thing, the structure of the graph. And eventually we break the structure of graph, right? And we use as a, we just consider it's like there's missing node, right? But yeah, it's not a fast and cheap way to be honest. It's not that bad. Like it's like how many nodes it's here? So it's around 3 million nodes, 2 million edges, and it runs in few minutes. But it's not that bad.